Hey, Algebra 2, here we are in section 6.3. Today we're going to talk about solving quadratic equations by factoring. I think it's really important. We don't have vocabulary. I think it's really important to start out with the basic concept here. And so the overarching concept that we're going to be using while we're solving quadratic equations by factoring is the fact that when I have two numbers, let's say A and B, and I multiply them together, and if I told you that A times B is equal to 0, this is a really special situation. It's special because it tells me something definite about each of these numbers. For instance, if I had A times B is equal to 1, I don't really know much about these like this. Both of these numbers would depend on the other one for a value, whereas this situation is very, very straightforward. I know for a fact that either A equals 0 or B equals 0. This is a fact, okay? Here, A times B equals 1, I couldn't tell you what's going on. I couldn't tell you if one was negative, well, if both were negative or both were positive. I couldn't tell you if one was a whole number, if which one was a whole number, which one was a fraction. For instance, like 5 over 1 could be A and 1 over 5 could be B, right? Or 1 times 1, or -1 times a -1. I mean, literally, there's infinitely many choices. 2020 over 3 could be one value, and the other one would be 3 over 2020. Like, literally, it could be anything. So anytime A times B is equal to a particular number, not that interesting. But when A times B is equal to 0, boom, we get something. A equals 0 or B equals 0. And this is like the foundation of what we're going to be talking about, how we can solve quadratic equations with factoring. So when you factor a quadratic equation, if you see this example here, this is a factored quadratic equation. We've got x plus 5 times x minus 7 is equal to 0. The rule applies. This is kind of like my A and this is my B. Because A times B is equal to 0, I know either A is equal to 0 or B is equal to 0. How does that translate here? Well, I know that either x plus 5 is equal to 0 or x minus 7 is equal to 0. And so with that, I set each of my factors equal to 0, and then I solve for x. So I'm going to subtract 5 from both sides, and then I get that x is equal to -5. Or I'll add 7 to both sides, and then I get that x is equal to 7. And so here, the power of the product equaling 0 is just wonderful, okay? So that kind of informs how we're going to process through the next few problems. So here in example 1, we see we do have an equation, and it is quadratic because we've got that x squared term. That's the highest degree term in the whole thing. Now, remember what I mentioned. I said, hey, we really love the A times B equals 0 situation, and that is going to be exploited by making sure anytime we try to solve our quadratic equations in this situation, we want ax squared plus bx plus c to equal 0. We're going to put everything on one side and set everything equal to 0. So you know what I'm going to do. I'm going to subtract or add -6x, as it were, to both sides. So I get x squared minus 6x is equal to 0. The next thing I'm going to do is simply factor. So I have to ask myself, how can I factor this left side of the equation? I'm going to factor out an x. Remember, taking out or factoring out the greatest common factor, which is x. So that I'm left with x times the quantity of x minus 6 is equal to 0. So here I have that situation, A times B. Not necessarily this AB, but two numbers multiplying together to give me that's going to equal 0. So if the product of two numbers is 0, I know one of them has to be 0. So I set x equal to 0, and then I set the other factor, x minus 6 equals 0. I'm going to solve. Well, this is already done. So one of the possible answers to this quadratic equation is that x equals 0. The other one, by adding 6 to both sides, is that x is equal to 6. So those are my two solutions for this problem. Moving on to part B, we have another situation where our equation isn't in what I'm going to call standard form, ax squared plus bx plus c. And so I'm going to put it in that form. I get 2x squared plus 7x minus 15 is equal to 0. Now what I'm going to do is factor this. And if you remember factoring, sometimes when you have a coefficient here other than 1, it can be a little bit more challenging. But 2 is kind of simple because I know that the only way for me to get 2 is to have 2 times 1. So I'm going to just write 2x here and x here. And then I have to figure out a way to factor 15 such that sometimes I call them the double V's. such that the linear term will add up to give me 7x. And so the two numbers that multiply to give me 15 would be like 5 and 3. So I'm thinking about those two numbers, and that feels kind of right, because if I multiply 5 here and a 3 here, if I put 5 here and 3 there, 5 times 2 is going to give me 10. 3 times x is going to give me 3, and I know I can do something with that to get 7. You might have a different way of factoring. This is not the time to go through all the factoring possibilities. I think that's fine. You can do it differently. But eventually, whatever way you're factoring, you should get that x, 2x, let me think what do I want to say, 2x plus minus 3, and then x plus, x plus 5. So 2x times 5 is going to give me 10x. Negative 3 times x is going to give me a negative 3x. And then when I'm done, I'm going to get a 7x. So I feel confident in my factoring. And so I'm going to get rid of this double V business. And then what I'm going to do is talk about the fact that x, this factor is equal to 0, or this factor is equal to 0. And setting each factor equal to 0, I am going to get the following result. 2x is equal to 3, or x is equal to 3 halves. And over here, I think you guys know it already, x is equal to negative 5. So these are my two solutions. And so notice in both of these situations, we got two different solutions, or what we call roots. So roots would be an x value that's going to make my function equal 0. So if you think about this in terms of, if you think about all of these in terms of the corresponding function, right? So you see how we ended up with this equation, and the corresponding function would be f of x, or y as it is equal to x squared minus 6x. If I were to graph it, you know I'd get a parabola. And if I were to get this parabola, wherever this parabola would be located, it would be happy, since the a term is positive and I can go forth and all that stuff. What I'm going to find is that the roots will be at 0 and 6, okay? So the roots are the solution to a quadratic equation, or the value of x where the function is equal to 0. You see what I'm talking about? And so similarly over here, if we were to graph this guy, and you can graph it, go ahead and put it in Desmos or put it in your graphing calculator or whatever. If we graph this, and when I say graph it, I mean the corresponding function, f of x equaling 2x squared plus 7x minus 15. If we were to graph this, it too would be a happy parabola where its roots are at negative 5, meaning the graph has a value of negative 5 when y is equal to 0, and it has another value of negative 3 halves rather when y is equal to 0 too. I don't like the way I'm saying that, so let me try it again. When x is equal to negative 5, y is equal to 0. And in this function, when x is equal to 3 halves, y is equal to 0. All right, and so that's what a root is. And so sometimes we could have two different roots like we have here, and sometimes we can have what we call a double root, which means the same root twice. Technically, it really means one root. And so let's go ahead and factor this thing. So if we factor it, you're going to realize that it's going to factor into, we're dealing with a perfect square trinomial. And so when we factor it, it's x minus 8 times x minus 8, right? Which is equal to 0. And then basically I have to say that x minus 8 is equal to 0, or x minus 8 is equal to 0, right? Same thing, which implies, or not implies, which basically says that x is therefore equal to 8. But notice in both of the roots we got the same value. I didn't write it twice because of that. And so what this means to me and to us is that we have a double root. It came up twice, the same thing twice. Okay, and so again, you know that I could write this as x minus 8 quantity squared is equal to 0. If I think about the corresponding function, f of x is equal to x minus 8 quantity squared, it would be a parabola that hangs out right here at 8, kind of just touches it right there, and it bounces. And so its value, oh, I made a mistake there. Let me see, I can't get rid of it. Let's try again. Boy, my pen is doing its own thing, so I'm a little bit nervous, but we're going to try to get through this video. All right, so we have this type of a parabola where it touches once. And yeah, so this is what a double root looks like. It's kind of a misnomer, right? Because it's not quite double in terms of what you're looking at. All right, so let's look at example 3. We're looking for the greatest common factor. So here's a multiple choice question. It says, what is the positive solution of the equation? right? And so one way we can handle this is to factor. So let's do that. So the first thing I want to do is to factor out 3, because that's going to make my factoring of the quadratic a little bit simpler. And we should always look for the GCF. Minus 20, okay, is equal to 0. And so now this is a lot easier. I get x minus, let's say, I think it's going to be like x minus 5 and x plus 4, okay? That's what happens when we factor, and then I'm going to set each of the factors equal to 0. It would be nonsensical for me to set 3 equal to 0 because 3 is itself. So I'm going to set the other ones equal to 0. And when I do that, I get that x is equal to either positive 5 or x is equal to negative 4. And I think you guys see how that would work out. And so you can see that the answer is 5. Now, the question that I would have is, if you were taking a standardized test and for some reason you forgot how to factor, you weren't sure what was going on, how could you try to do this problem? And my hope is that you would realize that if you were to substitute each of these answer choices, and I know that's a lot, but if you were to substitute the answer choices in, you would see that what is the positive solution? First of all, this is ridiculous because it's negative, right? So you wouldn't want to choose that. And the next thing you want to do is basically try the positive ones to see if it works. And what does it mean if it works? You would plug it in and it would satisfy this equation. When you plug in 2 or 5 or 10, you would see the answer would work out to be 0 if it is correct. And the only one that works for it is 5, and we saw it this way. So all things being all things, we're going to go kind of backwards here where we talk about example 4, which is to write an equation given roots. Write a quadratic equation with 1 over 2 and negative 5 as the roots. Then you're going to write the equation in the form ax squared plus bx plus c equals 0, where a, b, and c are integers. This feels like standard form in a way. Standard form, linear standard form, if you remember when we did linear equations. Anyway, so let's go. Write an equation, and here are my roots. And the quick and easy way to do this would be to say, let x minus 1 over 2 and let x plus 5 be the roots. Now, where am I getting this from? You remember when we were solving problems before that if we had something like, and I'm just going to thought bubble us for a second, and if this makes sense, you can kind of speed through this point. But if we had like x minus r and x minus y, as the answer to, is the factored way of doing the problem, when we set each of these equal to 0, we would eventually get that x was equal to positive r. Or let me change this to a positive y. And then here in this case, we'd get that x is equal to negative y, right? That was something we saw. And so this is a quick and easy way just to knock that out, okay? Just to say, okay, well, if x minus r gave me r as a root, then if 1/2 is a root, then x minus 1/2 must be a factor. Similarly, if x equaling negative y gave me x plus y as a factor, then here with this negative 5, I should have x plus 5 as the factor as well. And so now, before I foil this together to get the ax squared plus b plus bx plus c form, I'm going to do something here. You remember this last problem, how the 3 did not affect anything? I'm going to put a constant here. I'm going to multiply this whole thing by a constant so that I don't have fractions moving around. So I'm going to multiply this by 2. So when I do that, I get 2x minus 1 times x plus 5. Remember, I'm building this equation so it can be whatever I want it to be, as long as the roots are 1/2 and negative 5. And so now I've set up a situation where, remember before, if I didn't have this 2 here, this 1/2 would be all over the place, and I know a, b, and c would not be integers. So now I've got that taken care of. When I FOIL this, I get the following answer: 2x squared plus 9x minus 5 is equal to 0. All right, so that's it for this lesson. And I know that some of it was kind of quick. If you're feeling a little bit uncomfortable or if you need a little bit of help, just contact me and we'll make sure and clear up anything. Take care. Thanks for listening. Bye-bye.